Okay, and then we need to do the same thing again for this one. So we go back, second trace, number 5, and then go over here close to this one. Oh, wait, I did that wrong. Okay, 1.413. And then the last one is going to be 9 point something. Oh, oops. Second trace, 5. First curve, second curve. Yes. 9.822. I'm rounding to 3 decimal places there. You have to keep at least 3. If you want to keep more, if you want to write 9.8223, do it. If you want to write 9.822313, it's fine. It just has to be correct to 3 decimal places. Everybody good there? All right, part 2 says determine the end behavior of G as x increases without bound. Express your answer using the mathematical notation of a limit. So we need to use limit notation here. It's talking about end behavior. Which side is it asking us about? The right side of the graph or the left side of the graph? It's right, because we're increasing without bound. That's going to be the right side. So we're going to write limit as x approaches positive infinity. What would it say if it meant the left side? We'd use negative infinity on the limit notation, and the words would say decreasing for that. For this, and you must put g of x right here. That's important. If you just have limit x approaches infinity equals, then you're not telling me which function you're talking about, and it's not going to be correct. All right, what happens to our y values as x approaches infinity here? Increase. And so if they increase, we'll have positive infinity for that. Okay, best I can tell, C is always going to ask you about if a function is invertible and why. Or at least that's what Mr. Passwater's doing on all of his. So, and I'm pretty sure it was on the practice test as well whenever I looked at this. So, part 1 is just asking you pretty much a yes or no question. Determine if an inverse function of f can be constructed for all values in the domain of f. It is a no. And then 2 asks you to give the reason. So this is a no. Because what do you do whenever you find an inverse? Switch x and y's. Okay? So if I switch the x and y's, these are now my x's, these are my y's. Is my inverse a function? It is not, because the 4 gets repeated. Right? So this is a function because the y's can repeat. But if I have a repeated y, when I switch x and y's, now my x's are repeating. Let's think about it with a graph. I'm going to zoom out a little bit here. So this one's asking you about f of x. It's asking you about the table. It's not asking you about g of x. Why didn't that zoom out like I wanted to? I hit the wrong button. So if I think about like what this graph looks like, this is something I probably didn't talk about enough whenever we were doing these problems. But in order for there to be an inverse, your function has to be what we call 1 to 1. That means each x just has one y. And each y only has one x, right? 1 to 1. A lot of times I'll talk about it when I'm teaching it like Math 1, like if you think about like a marriage relationship, it'd be the difference between like completely monogamous, like every person only has one spouse, versus, you know, the more closer to reality that's not one-to-one, that some people have married more than one person, right? Like you got divorces and remarries and all of that. So like one-to-one is every X has one and only one Y, right? So the X's cannot be repeated and the Y's cannot be repeated for that. That is a one-to-one function, which means that your function should pass the vertical line test and the horizontal line test. Does g of x over here, does it pass the horizontal line test? If you try a horizontal line, it's going to hit more than one place, right? If you just look at like what they already asked you about B1, there were 3 places where you had that same y value, right? So g of x, it's not asking us about g of x, but g of x is not a one-to-one function. Now, it has been pretty clear on the stuff that they have produced. You cannot talk about vertical and horizontal line test as your reason. While it's good to help you think about it, you can't use it as your reason. So, like, I can't say in part 2 that the function does not have an inverse because it does not pass the horizontal line test. They won't count that as your answer. So, this is what your answer should look like for this. They're asking us about F. So, I would say for the first part, it's really just a yes or no. You might get away with just saying yes or no, but all the answer keys I've looked at have it written as a sentence. So, it says determine if an inverse of F can be constructed for all values in the domain of F. So, I would say an inverse function of F can not be constructed for all values in the domain of F. Use their words. Just rewrite what they've done. This is like a little bit like in, you know, 2nd grade when they made you write all your answers as sentences, and it was so annoying. It would be like, you know, what color is the dog? And instead of just putting brown, you had to put the dog is brown, right? You might can get it by with just saying no here. I'm not sure, but I wouldn't risk it for the sake of just not wanting to write it out. There. Then part 2 is asking you for your reason. So, your reason here is because F is not a 1-to-1 function. And how do we know F is not a 1-to-1 function? Because there's a repeating Y. If we're talking about F, it's a repeating Y value, right? I would say, what I would do for this is I'd say F is not a 1-to-1 function because I would just do this. F of 2 equals 4 and F of 5 equals 4. Therefore, if I use those dots before, you can use those if you want. It's a mathematical symbol. Those 3 dots in a little triangle, that means therefore. So if you want to write it instead of the word therefore, you can. And it's okay because that is a mathematical symbol that means therefore. So therefore, you could word this a couple. I would just say the inverse of F is not a function. Or you could say something like, therefore, an inverse function of F cannot be constructed for, you can kind of make the claim you made earlier. You might get by with just saying f is not a one-to-one function because f of 2 equals 4 and f of 5 equals 4 and not make that final conclusion, but I would write it this way for that. Okay, here. All right, we are going to skip down to the third one. So the second one that you've got is similar. You got a different table, you got a different graph, but similar questions. We're going to skip to the one that has the graph that looks like this, right here. And this one tells us the figure shows the graph of the decreasing function f on its domain of all real numbers where x does not equal 1. The points -1, 0, and 3, 2 are on the graph of f. The function g is given by g of x equals 2 plus 3 natural log of x. So if you wanted, you could go over here and type in that equation, 2 plus 3 natural log of x, if you just want to, or you can wait till you need it, either one. They did tell us -1, 0 and 3, 2 are on the graph of f. So they're just giving you those exact points so you know, yes, those really do cross that grid lines there. They didn't tell us 0, -1, although I feel like that's probably on there. Don't know if we should make that assumption if we need it, though. So notice the question for part A, number 1, is almost exactly the same as it was on the other problem, right? The difference here is they're asking us for h of 3. So we'll need to do h of 3, which will be g of f of 3. First, we need to find f of 3. What is f of 3? It is 2. To find it from a graph, your x-coordinate here is 3. The y-coordinate that goes with it is your f of 3, and that is 2. So we got g of 2. And this one's really not that hard to find. You can do alpha trace y1 of 2, or you could just type in the number 2 plus 3 natural log of 2. Either one is going to give you 4.079. Notice again, I didn't write any of the work out for that. But I do want you to write the part I'm showing you right there. Write that stuff. Okay. Part 2 says find all real zeros of f or indicate there are no real zeros. What are the real zeros of f? Just -1, right? The zeros, real zeros, are your x-intercepts. They gave you a graph. You're just looking for your x-intercept. That's right here. All right, so you would just say f has a real zero at x equals -1. I think you'll probably get by with it if you just put x equals -1. It doesn't hurt to write the sentence. Okay? Everybody good there? All right. B1 says find all values of x as a decimal approximation for which g of x equals e, or indicate that there are no such values. What should I do here? We're going to see where it crosses e. So we're going to go over here to y equals. E is the y value, so we're going to put in y2, we're going to put an e right there. We are going to graph it. I bet I need to go zoom 6 again because I zoomed out earlier. Oh yeah, I can't see that. Do zoom 6. They're only going to cross at one point there. I'm going to do intersection just like I did before. So second trace, number 5 intersect. You may have to go over a little bit because mine wasn't showing up. And then you hit enter, enter, enter. And I'm getting x equals 1.271. And if you want, you can say g of x equals e at x equals 1.271. Hello? Miss Mullis needs to see you for a second. So, I'm recording so you can watch that. Tell her that Jade left early, so she needed her, but she's not here. All right. Then ask us for end behavior of G. Is G the graph or the equation that we have graphed on our calculator? Equation on the graph of the calculator. So we're looking at this one here. Is it asking us for right side end behavior or left side end behavior? Right. So we're going to do limit as x approaches infinity. Make sure you put a g of x here. And what happens as x approaches infinity? What do we approach? Positive infinity. Sometimes natural logs can look a little bit like they got a horizontal asymptote, but they don't. They have vertical asymptotes. You're either going to get positive or negative infinity for those. Okay. Notice the similarities in these questions and the other one that we just did. C is not worded exactly the same, but it's asking the same thing. Determine if F is invertible. First of all, is F what I've got on the calculator or the graph up here? Graph up here. So we're not looking at the calculator. We're looking here. Make sure you're looking at the right thing because earlier I was using G for this and I messed up. This just means can you take the inverse of this. In order for you to be able to do the inverse, you have to have a one-to-one function. In this case, would this pass a horizontal line test? Is there anywhere where I touch the graph twice? No. This passes the horizontal line test. So, this is invertible, so I would just say, yes, F is invertible. Because the reason needs to be given in part 2. Give a reason for your answer based on the definition of a function on the graph of y equals f of x. I can say since y equals f of x is a 1-to-1 function, f is invertible. There. All right, questions? All right, so the other two are going to be your homework.